Now let's see this function mod x. The importance or why this function is very interesting is it behaves in two ways. So we know about mod x, whatever input we give it, the output is going to be a positive number which is equal to in magnitude to the input. For example, if I give it like this, so if I apply mod to -3, it is going to be +3. If I apply mod to +3, it is going to be +3, which means either you give a negative value or a positive value, output is always going to be positive, and the output is equal to the input in terms of magnitude. Okay, that is the reason why this function is interesting. So let's write this definition of the function, and then we shall see why we have to analyze it here. So let me write the definition of this function. Now f of x is equal to minus x when x is less than 0. Let's say x is less than 0, and it is equal to plus x when x is greater than 0. Here I think you will get some doubt. The doubt is when we are saying that f of x mod x has to be always a positive number, why are we writing it as minus? Here minus, that is a doubt, a very popular doubt. The reason is simple. See, even though I am writing the value number as minus x, right, but x is less than 0. Check this. So if x is less than 0 means x is a negative number, which means inside this number x itself we have a negative sign, and outside we have a negative sign. Therefore overall it is going to be positive sign. Now when x is greater than or equal to 0, then what happens? That it is already a positive number. That is why we are not putting any sign there. Therefore the output is going to be positive. That is the reason, right? And now if you observe this, this mod x, this function seems to change when x is at a point 0, which means this function is going to change at a point 0. Therefore at that point 0 they are asking us to analyze it. Now check this. Discuss the limit of f of x at x equal to 0. Now what did I say? The limit exists at a point whenever its left hand limit as well as right hand limit both are equal to same, right? Now let's find out what is the left hand limit and right hand limit here. See, watch it. Left hand limit of mod x, which is nothing but f of x here, at x equal to 0 equal to limit h tends to 0, right? Which means I am going to take this. What is h? H is a small infinitesimally small positive number. Okay, limit x tends to 0 f of x minus h. In this case it is going to be 0 minus h. Why 0? Because we are talking about at x equal to 0, right? So what does it mean? In place of x you are supposed to substitute 0 minus h in this, so that equal to mod 0 minus h, right? So we know that already h is a positive number which is small, and 0 minus h is definitely a negative number. So since it is negative number, we are going to have h. H is a positive number, minus h is a negative number. So when we give it a negative number, output is going to be h itself, right? Now we have to apply limit h tends to 0. Limit h tends to 0 here and here, right? Limit h tends to 0 here and here. So which is nothing but 0. The left hand limit is equal to 0. Now let's examine the right hand limit as well. So what is right hand limit? Right hand limit of f of x at x equal to 0. What is right hand limit? We have to go some point beyond that x in the neighborhood of x, equal to limit h tends to 0 f of, we are talking about at 0 plus h, which is nothing but limit h tends to 0 mod 0 plus h, right? So what is this? H is a positive number, therefore mod 0 plus h is nothing but h, which is simply limit h tends to 0 positive h, which is 0. Therefore we got 0 here and 0 here. Therefore left hand limit is equal to right hand limit for a point x equal to 0. Therefore limit exists at x equal to 0, and the value of that limit exists at x equal to 0, and the value of that limit is 0 itself, right? So the answer is the limit exists at x equal to 0 and the value of limit is 0 itself. Okay, now let's discuss the question number 2. Now I think we understood how to find out whether a limit exists at a value a or not. So I'll just put it together in small kind of definition, and then what I'll try to do is I'll explain you the second question in this. The second question is also discuss the limit for all x in its domain, which means they are asking us, now we have discussed about what happens at 0, now they are asking us to say what happens at every possible value. So just before going ahead, I want to discuss about the definition. So when do we say that a limit exists? See this. So we say that a limit to a function exists if, what is the condition? If left hand limit is equal to right hand limit. Now how to find out the left hand limit or right hand limit of a function exists at a, okay, at a point x equal to a, limit of a function f of x, okay, that is the meaning. So now when do we say that it exists? It exists when left hand limit is equal to right hand limit. Now what is the left hand limit? Left hand limit is nothing but we have to talk about the value of the function at a point left to it, right, in the neighborhood, which means if f of x is the function, we are supposed to find out the value of f of x at the neighborhood of a, which means a minus h is nothing but, see, we are talking about the value of f of the function f at a value which is somewhat less than a in the neighborhood of a, isn't it? Limit h tends to 0, right? This is left hand limit. Now what is right hand limit? We have to talk about the value of the function to the right of it, which means limit h tends to 0 f of a plus h, right? Now whenever this value becomes equal to this value, then we can say that limit exists. That is what we have been doing till now. Earlier, if you observe the two functions that we have observed, which means x square minus 4 by x minus 2 as well as mod x at value 0, and the earlier function was at 2. Now if you observe these two functions, we discussed about the limit, we found out that these two values happen to be same. That is why we have decided that we declared that limit exists, right? Now similarly, they have wanted us to discuss about when the limit or about all the values of x, right? Discuss the limit for all the values of x, which means they wanted us to what they wanted is they wanted to ask whether the limit exists for every value of x including 0. 0 is already done. Now we shall discuss about the other remaining values. What are the remaining values we have here? See this. So one value is we can have x less than 0, right, which means we want to discuss about negative numbers. Let's say case 1 is x less than 0, which means x is negative, right? So let us say x is negative. So when x is or instead of writing x, let us discuss about set of all negative numbers. Let us say a represents a value which is less than 0. Now we want to discuss whether the limit exists at a or not, which means for the negative numbers I want to discuss about it, okay? Now left hand limit is what? See this is left hand limit, isn't it? Left hand limit is limit h tends to 0 f of a minus h, where h is a very small positive number, isn't it? That equal to limit h tends to 0. See, f of x equal to mod x, then f of a minus h equal to mod a minus h, isn't it? Now it is a positive number. If we have a negative number, and from that negative number if you are going to subtract a negative number, right, from a negative number if you are going to subtract something, still the answer will be negative, which means this entire number a minus h is going to be a negative value. So when it is going to be negative value, we are going to have minus a minus h as its output, isn't it? Therefore the value of this one is nothing but this with limit h tends to 0. Now if you substitute h tends to 0, we are going to get it as minus a. Fine. Now let's find out right hand limit as well. Right hand limit, see this, right hand limit is this one. What is it? Limit h tends to 0 f of a plus h. What does it mean? Limit h tends to 0, a plus h is nothing but, f of a plus h is nothing but mod of a plus h, right? Now a is a negative number, to which we are going to add a very small infinitesimally small number which is positive, even then the entire limit is going to be negative itself. See, only way you can make this as positive is when a is very very small, and when you are going to add it, it is going to become 0, isn't it? Even then the same thing will occur. A plus h will be true. See, h is a very small number and a is a negative number. This is positive. In case if it is also a negative number which is very small, then also in the worst case this entire value will become 0. Therefore minus of 0 is 0, so it doesn't, we can write like that. Or in all the other cases, if a is a big number and h is a very small number, and since it is a negative number, so we are going to get the entire result as negative, right? And we cannot say that what if a is a number which is very very small than h. Already I am saying that h is the least smallest number possible. There cannot be. If you are going to take a value of a which is very small, then what I will do is I will take the value of h which is even smaller. That is how we find out the neighborhood, isn't it? See, if a is a number, we are going to take a very very small number across its neighborhood, which means this entire number will never cross 0. That is the meaning of it. So if you say that it is a is very small and it is less than h, then I'll say that I'll take a small number which is even lesser than this. So what I mean to say is, whatever you go for the value of a, I'll still get a lesser value compared to a for h. Then in worst case it might go to 0 or it will be less than 0. Therefore the entire value is going to be less than 0, and so I'm going to put it as minus a plus h, since it is going to be a negative number, right? So in that case, if you put limit h tends to 0, which means in place of h if you put 0, this one is going to be minus a. So both of them you have to apply limit h tends to 0. Then you are going to get that left hand limit is equal to right hand limit, and so the limit exists for all values of x less than 0, which means for all the negative numbers limit exists. Already we know that the limit exists for 0. Now we are showing that the limit exists for values less than 0. Now we have to show that the limit exists for values greater than 0. Okay, now see this. What happens for limit greater than 0? So let us say case 2. Case 2 is a is a number which is greater than or equal to 0, and equal to 0 is already discussed. So let's discuss about only 0, which means we want to discuss about whether the limit exists at a point a if the a is positive number, and a can be any value. Okay, so let's talk about left hand limit. So what is left hand limit? Limit h tends to 0 f of a minus h. A minus h means a point just left, just to the left of it. Then what do you get here? So this value is going to be limit h tends to 0 mod a minus h, isn't it? Now a is a positive number and h is a very small number compared to a in general, otherwise it will be as big as a. That is the worst case, right? Then what happens? In worst case we might get 0, otherwise it will be a positive number. Therefore this entire number is going to be 0 or positive number, so I can directly write it as a minus h, which is going to be positive or 0. Got it? So what can you say about it? Limit h tends to 0. Now what do you get it? A. Okay, now find out the right hand limit. So how to find out the right hand limit? Limit h tends to 0 f of a plus h, which means we are finding out the limit at a point just in the neighborhood of a, but a small deviation to the right of a. Okay, so what is it? That equal to limit h tends to 0 mod a plus h. Already a is a positive number to which I am going to add h. The total result is going to be positive because h is also positive. So what can we say? It is nothing but limit h tends to 0 a plus h. So what is a plus h? When you substitute h equal to 0, we are going to get a. Now left hand limit and right hand limit both are equal even for positive numbers. For negative numbers both are equal, for positive numbers both are equal, and for 0 also both are equal. Therefore this function, limit exists for every real number. For every real number you could think of it. You think of any real number, limit exists. Okay, so that is the meaning of this one. Fine. So now we can Okay, see, one more thing, you need not do the entire proof in gate. If you can remember this, I'm talking about some of the standard functions, some of the popular functions. Just remember the result. This is how we are going to prove it in theory exams. If you have any BTech theory exam, or if you are preparing for IIT JEE, if anyone watching this video is preparing for IIT JEE, for them the proofs are important, and other theoretical exams the proof is important. But coming to gate, it is important that you just remember the result. Result is just enough. Yeah, even if you think that is going to be very big, you are not going to do it in the exam. Just remember the result. What is the result? For mod x, limit exists everywhere. So there are some very popular functions. All those functions we shall discuss. Okay.